This time, class, let's talk about the liquid state of matter. Okay. So, what are some of the properties, class, that we will be discussing about liquids here? So, basically, class, we'll be talking about first the vapor pressure, followed by the surface tension and the flow properties or viscosity of our liquids. But actually, class, we have a separate discussion for this, for surface tension and flow properties. So, for the class, we'll be focusing more on vapor pressure. Okay. So, what is vapor pressure, class? So if a liquid kasi is placed in an evacuated container at a constant temperature, the molecules with the highest energy will escape and pass into the gas state, while some of them will condense back into its liquid state. So basically, class, if pinabayaan ko halimbawa isang basong tubig. Okay, ito isang basong tubig. Alright? Hayaan ko lang siya dyan, class. Technically, class, this glass of water is actually producing some vapors already. Lalo na kung nasa room temp lang tayo. Because not all molecules of liquids, class, have the same energy. Some have higher energy. Okay? Let's say, for example, lalo na, class, kung nasa initan tayo. Halimbawa, ayan, lagyan ng araw. Okay? So, obviously, class, pag may araw tayo dito, yung first layer ng water natin will have higher energy as compared to those water underneath it. Tama? So, ang tendency, class, those water with higher energy can tend to transcend or can tend to evaporate na. Okay? So, they start evaporating. Now, class, as they evaporate, they're creating what we call a vapor pressure. A pressure that is exerted by the molecules of that fluid that is evaporating. Okay? Make sense so far? Okay pa naman? Okay. All right. All right, good. So if the rate of vaporization, class, is equal to the rate of condensation at a definite temperature, then we say that there is a state of dynamic equilibrium. Kasi, class, take note of this, as some of the molecules are becoming vapors. Okay? May iba dyan nagiging vapors. Matandaan nyo, class, at the same time, dahil malamig ang tubig natin, some of them can actually go back to being droplets. So some of them are starting to condense at the same time. So that's the reason why, class, kung titingnan natin yung figure dito, palitan natin yung ano. Okay, let's just change the pointer. Okay. So if you look at the figure here, class, here is the phase, the transition phase between gas and liquid. So sabi ko sa inyo, class, they are continuously evaporate. Water molecules, or sorry, the molecules of that liquid is continuously evaporating and condensing at the same time. Okay, ang nagkakatalo na lang ngayon dyan would be, mas marami bang nag-evaporate kaysa nagko-condense or vice versa, or equal ang rate of condensation sa rate of evaporation. Kasi, class, kung equal ang rate of condensation sa evaporation, then we say that the system is in a dynamic equilibrium. Okay? It's in dynamic equilibrium. Ibig sabihin, the amount of drug evaporating is equal to the amount of fluid evaporating is equal to the amount of liquid that is condensing. Right? So the pressure of the standard saturated vapor above the liquid is known as the equilibrium vapor pressure naman. Okay, yun naman, class, yung pressure na nilalabas ng saturated vapor natin. Okay? Now, if the temperature is increased, more liquid will obviously pass into gaseous states, therefore increasing the vapor pressure. Therefore, class, vapor pressure increases with rising temperature. So similar, class, to what we have in the gas laws. Okay? Sabi natin, as we increase temperature, we increase pressure. So sa gas, ganoon. Okay? Sa gases, as we increase temperature, we increase pressure. Same thing, class, happens with liquids. As we increase temperature, we also increase the vapor pressure. Okay? So again, class, it's simply the pressure being exerted by the molecules of that liquid that is changing from liquid to gaseous states. Okay? So basically, class, this is what happens here. In a enclosed system, sabihin natin enclosed system to. Okay? Kunwari, at 20 degrees Celsius. Sabihin natin, class, ito yung rate of evaporation. Okay? The rate of evaporation is constant. Okay? Now, class, if I leave it there, basically, some of the molecules, kahit hindi yan kumukulo, some of the molecules, class, will still start to evaporate. Just take note, even at 20 degrees Celsius, some of the molecules of this water will be energized enough to evaporate. Okay? So some of them will evaporate. So what happens here now? Dahil closed ang system, okay, it's in a closed system. Yeah, may umbok pa tayo ng konting maliit. Okay, so it's a closed system class. Sooner or later, makakahabol yung rate of condensation. Okay? Once na na-reach na yung rate of condensation, ang rate of evaporation, yung point class wherein nagtugma ang rate of evaporation at rate of condensation is what we call the dynamic equilibrium. Okay, make sense? All right. Now, what will happen kaya class sa system natin if I start increasing temperature? Okay? As I increase the temperature class, obviously, okay, mas dadami ngayon yung mag-evaporate. Okay, mas madaming molecules ngayon ang mag-evaporate. So therefore, class, filling the container or filling the system, okay, with vapor molecules, with gaseous molecules. So ang tendency, class, is, ang nangyari ngayon sa rate of evaporation, tumaas. Excuse me. So as I increase, class, the temperature, tumataas din yung rate of evaporation, obviously. Okay? So therefore, class, dahil dahil tumaas ang temperature ko, ang tendency, tataas din yung pressure ko sa loob. Okay? So sabi nga natin, directly proportional si pressure at saka si temperature, even for fluids or for liquids. Now, what happens here, class, since dahil enclosed ang system, ayan ulit tayo, ha? The system is closed. Okay? Darating ang panahon, class, mahahabol pa rin ni rate of condensation si rate of evaporation. Yun nga lang, mas matagal. At the same time, mas mahaba ang proseso. Kasi mas mainit yung tubig. Pero as long as the system is enclosed, na-maintain yung temperature na yan, mahahabol ni condensation yon. At pag nagtugma ulit si rate of condensation sa rate of evaporation, meaning the amount of liquid turning into gas is equal to the amount of liquid going back into liquid form, the amount of gas turning back to liquid form, okay, then hence, class, we start to reach again what we call the dynamic equilibrium. So are we clear? Okay, so as I told you a while ago, class, if the system is open, obviously, kahit hindi yan kumukulo, class, some of the molecules of our water, remember this, even if you don't apply too much heat, water, the liquid can still evaporate. Kaya nga, class, leave a glass of water outside overnight. Balikan mo kinabukasan. Same amount pa rin ba yan? Wala namang mainit nun. Di ka naman masyadong apply ng heat doon, di ba? Kinabukasan, kasi makikita mo, mawawala na yung tubig sa loob ng baso mo because some of that water have already evaporated. Okay? Now, class, if I enclose that system, okay, evaporation which has reached equilibrium with the liquid surface is said to have reached its saturation. Okay, basta provided, class, na enclosed yung system natin. Right? So here are just example, class, of the vapor pressures of several liquids as a function to temperature. So notice, class, most of the time, depending actually sa ano din to sa liquid, kung ano yung gamit mo. Okay? Pero some liquid, class, like say for example, mercury. Obviously, you need a high temperature to allow it to boil. Kasi metalloid ito eh. So at the same time, class, the vapor pressure of this mercury, okay, would usually reach around 760 siguro to 750 millimeter of mercury, okay, para lang mag-start siya mag-boil, right? To reach 1 atmospheric pressure. Kasi, class, one of the requirements, okay, take note of this, one of the requirements kasi, class, for a liquid to boil is that yung vapor pressure mo is equal to the atmospheric pressure. Okay, meaning sa pressure ng surroundings mo. So sabi nga natin, class, ano ang usual na atmospheric pressure natin dito sa bahay? It's usually 1 atmosphere. So meaning, class, my vapor pressure, if I want to boil a liquid, okay, dapat yung amount of vapor pressure na napoproduce ko should also be equal to 1 atmosphere. Or probably even higher than 1 atmosphere. Okay? Kasi, class, once na-reach mo na yung 1 atmosphere na yon, the vapor pressure, then your fluid will start to boil. Okay? Mag-upisa na siya mag-boil. Kidoks? Okay. So, just remember, class, that 1 atmosphere is equivalent to 760 millimeter of mercury. Kaya sabi ko dito, mga 750 or 760 to. So, this is already at 1 atmosphere din. So, for, wag na lang si ethylene glycol. Okay? Ang temperature niya is approximately here. Dito, sa 100 something. Water na nga lang, ba't ba ako nagpapakahirap? Si water na lang. Okay? Si water, class, tingnan nyo, at what temperature siya mag-start mag-boil? If you trace it, class, it says here, it's at 100 degrees Celsius. Why? Because at 100 degrees Celsius, ang vapor pressure ni water is around 760 millimeter of mercury, or what we call 1 atmosphere. So at this temperature, water starts to boil. So are we clear? So yun kasi ang significance ng ating vapor pressure. Kasi, again, if you want a liquid to boil, okay, if you want something to boil, class, the vapor pressure that that liquid is producing should be equal to the atmospheric pressure, which is most often than not, class, equal to 1 naman. Okay, now, class, let's talk about heat of vaporization. Right? When we talk about heat of vaporization, class, it's defined simply as the amount of heat. Take note of this, this amount of heat. Okay? So when we say amount of heat, class, oftentimes we are referring to energy. Okay? How much energy is being absorbed. So it's usually expressed, class, in the form of joules, ergs, pwede rin naman, or liter atmosphere. Okay? So nasabi ko to kanina, di ba? Pero most often than that, class, it's either expressed as joules or calories. Okay? As a form of energy. So heat of vaporization, class, is simply defined as the amount of heat needed to turn 1 gram of liquid into vapor. Okay, 1 gram of liquid into vapor. So if I'm computing, class, for my heat of vaporization, I'm simply thinking or asking or trying to find out how much heat do I need to convert 1 gram of my liquid into vapor state. Right? 1 gram of my liquid into vapor state. Right? Ulti ko, gram. Meaning I'm looking at the amount in terms of its mass. Okay? Okay. So the relationship between the vapor pressure and the absolute temperature of a liquid, class, is expressed by the may pronunciation to Clapeyron. Parang Clapeyron siya, pero it's Clapeyron equation. This is the combination, class, of two equations by Clausius and Clapeyron. Si Clapeyron, class, na ito, mamaya lalabas to sa solids. Or pwedeng next meeting na, depende kung kailan natin i-discuss yun. Okay? I'll show to you the Clapeyron equation na siya lang. Okay? Ito kasi combination na to ng equation ni both Clausius and ni Clapeyron. Now, class, anong ina-express nila dito? Okay? P2 and P1, class, is simply the vapor pressures at absolute temperatures in their corresponding temperatures. Okay? Now, the change in your heat, okay, or what we call the molar heat of vaporization. Okay? Ito yun, the molar heat of vaporization. Iba-iba lang ang pagkakasulat, pero we're just talking about the same thing. Okay, yung change V up HM na yan is just your molar heat of vaporization, or meaning the amount of heat you need. Okay? Is simply the amount of heat, class, absorbed by 1 mole of a liquid when it passes into vapor state. So meaning, excuse me. So this is the amount of heat absorbed for every mole of a liquid. Every mole. Alam naman natin kasi sa mole, di ba, refers to grams per molecular weight. Okay? Grams per mole. Okay, so when it passes into vapor state. So again, this one, class, basically measures the amount of heat. Okay? Amount of heat needed to convert 1 mole of your liquid into vapor state. Okay? Kasi pag sinabi natin heat of vaporization, right, it's the amount of heat needed to turn 1 gram of your liquid into vapor. Okay? Pag molar heat of vaporization, class, it's the amount of heat absorbed by 1 mole and then it's converted into vapor. Now, alam niyo naman siguro, class, di ba? Pag naka-mole na yan, I can easily convert it into weight. Right? Provided I know the molecular weight of my substance. So, are we clear? Are we good? Okay? Kasi, class, halimbawa, pag pinakompute ko sa inyo, wari lang, sinabi ko, class, give me, how much heat do I need to give to my system to convert 1 gram of that system into chuba-chuba, into vapor. And then, of course, class, we have the R again, which is known as the gas constant. Okay? Lumabas to kanina sa PV and RT. Kanina kay ideal gas law. Okay? Lumabas na to kanina, di ba? Yeah. Anyway, so class, yung gas constant natin can either be expressed in, kaya in-express natin siya in liter atmosphere. Okay? This one, class, is expressed in joules. Okay? Kelvin per Kelvin mole. Okay? So 8314 joules per Kelvin mole. Okay? Or 1.987 calories per Kelvin mole. That's our gas constant. Again, kasi magkakatalo lang naman yan depending on what units are given to you. Okay, so ikaw na rin naman pipili yan afterwards. Now, notice here class meron siyang ln. You're familiar with ln? ln stands for natural log. Okay, natural log kasi class shows the relationship, the increase, the growth, okay, the relationship of two factors when growth is involved. Okay, in this case class, ang lumalaki dito kasi is heat. Nag-growing heat, either lumalaki or bumabagsak. Kaya class, it's best to explain this, the equation daw, using a natural log system. Okay? Okay? Ang ln na yan, class, sa calculator nyo, I don't know if you can see this, it's here. Wait lang. Okay? It's, whoops, may ganun-ganun. It's here. Alright? Natural log. I don't know if you have, ln, hanapin nyo sa calculator nyo. Nakita nyo ba yun? Katabi siya ng log. Did you find it in your calculator? Yeah? Yes, okay. Yes, very good. Yan, ln yan. Okay? Now, you see, class, diba, log, pag sinif mo, ang lalabas anti-log. Pag ln kasi, ang lalabas yan is the base of the natural log, or what we call the Euler's system, the Euler number. Pero anyway, next time yun ang pag-usapan yun, basta tandaan nyo lang muna, pipindutin na dyan is ln. Okay? Ang opposite ni ln is e. Try nyo, press shift ln. Tingnan nyo lalabas.
Letter E po, sir.
O, diba? Letter E. That's actually class called the Euler's number. Okay, Euler's number. Or kung titingnan natin, parang Euler's number, right? Pero it's called the Euler's number. I don't know why it's pronounced like that. Okay, anyway. Yan, basta E. Yung opposite na natural log. Kung si log may anti-log, si natural log may Euler's number. Or basically, we call this the base of the natural log. Right? Pero anyway, so here's the formula here, class. Now, let me try to break it up for you muna. Okay? Now, please take note of this before I proceed any further. The heat of vaporization, class, if we want to convert liquid to gas, obviously, ano dapat ang heat ko? Positive or negative? I should be gaining heat, correct? So hence, class, the heat of vaporization, if you're converting liquid to gas, should always be positive. Okay, positive ang value niyan. Meaning, you need to be gaining, you're gaining heat, right? Now, class, pag negative kasi ang value na lumabas dyan, ibig sabihin nun, your gas is converting back to its liquid state. So, kumbaga, class, using the Clapeyron equation, I can determine how much heat do I need to give to my liquid to convert it into gas, or how much heat do I need to remove from my gas to convert it back to liquid. Okay? At a given state or scenario. At a given system. Pag sinabi ko at a given system, may given time pressure, meron din tayong available temperature. So are we good? Okay, nag-gets ba? Ganun siya, class. Okay? Kaya nga meron tayong P2, P1. Kasi baka may baguhin tayo sa mga parameters na yan. Okay, may baguhin tayo sa mga pressure niya after a while. Okay, and so on and so forth. Now, we were able to derive this class using, para lang ako mapadali ito. Kasi mahirap tingnan siya na ln ganito. ln P2 divided by P1. Okay? Now, class, kasi I personally prefer this to be in linear format. Now, normally, class, if you're using a logarithmic expression, di ba pag fraction yung inipit natin between a logarithmic expression, technically that's ln P2 minus ln P1. Okay? Yan yung expression pag logarithmic siya. Pero if you want to simplify it, i-enclose mo ng pareho, gawin mo siyang fraction, P2 over P1, tapos ln ilagay mo sa labas. Right? Pero again, personally, I prefer it to be in its linear format. So, ganito siya itsura niya. ln P2 minus ln P1. Negative to, class, again, importante lang yung negative sign na to if we are going to convert gas back to liquid. Okay? Yung negative sign na to. Importante itong ilagay if we're going to convert gas back to liquid. Pero no, most often than not, kaya papakita ko sa inyo dito would be liquid to gas. Okay? So, we're going to add heat. Maglalagay ako ng heat. So, tanggal natin yung negative sign na yan. So, normally, class, ang lalabas na equation natin would be ln P2 minus ln P1 is equal to the heat of vaporization, the molar heat of vaporization, divided by your gas constant, times 1 over the T1 minus 1 minus over T2. Okay, the first temperature of your, the temperature of your first system, tapos ano yung magiging temperature ng second system mo. Gets? So, class, yung P1, P2 dyan, T1, T2, halimbawa, kasi tandaan nyo, I'm converting, this is heat of vaporization. I'm converting either liquid to gas or gas to liquid. So say for example, class, ganito. From a liquid siya. Liquid ang aking gamot. Ang aking substance. Huwag mo tayo maggamot. Substance ko. So class, obviously, I can have the current pressure here. Ano ang pressure na meron ako dyan sa system, sa liquid ko? At ano ang current temperature niya? So kunwari, 1 atmosphere, tapos 25 degrees Celsius. Okay? Now, I'm going to convert it to its vapor state. Say, for example, vapor state. Okay, gusto ko siya maging vapor state. So, obviously, I need to know the critical temperature of my liquid. Okay? So, halimbawa, ang critical temperature niya is, or kung alam ko, kunwari, critical point niya na ha, kunwari, alam ko na. Alright? Kunwari, alam ko na yung critical point niya. So, ang gas state niya, so, ang critical point niya, ang crit pressure, okay, would be, kunwari lang naman to ha, 50 atmospheres. Kunwari lang ha, kunwari lang. Okay, tapos ang temperature, ang critical temperature niya, okay, would be, say for example, 120 degrees Celsius. Okay, yun yung critical temperature niya. So obviously class, if I want to make it into gaseous state, either I reach 120, okay, or I can go beyond that a little bit. Depende na sa akin yun. Okay, pero sabihin natin, gusto ko lang sakto critical temperature. Right? At least I know, if I go beyond that, sigurado akong gas na to. Or nag-uumpisa na maging gaseous yung liquid ko. So with this class, with this in mind, ang tatanong ko lang naman dyan is, how much heat do I need to put into the system to convert my liquid to gas? Nagets ba? Nagets ba, class? Okay. So yun, class, makukuha ko doon yung heat of vaporization ko. Actually, una ko makukuha is the molar heat of vaporization. Then using that molar heat of vaporization, given ako ng molecular weight ng substance ko, I can compute for my heat of vaporization. So molar heat of vaporization would simply be equal, bago ang lahat pala, although pwede rin naman. Sige, gano'n na lang. Okay. So heat of vaporization would be equal to ln P2 minus ln P1 times R times P1 minus T2. Okay? So again lang, makuha ko na yung heat of vaporization ko. Tapos pag nakuha ko na si heat of vaporization, molar heat of vaporization, sorry. Okay, so dahil class ang lalabas dyan is joules per mole. Okay? So ang kailangan ko lang naman dyan is joules per gram. Okay? So yung moles na yon, i-convert ko lang into as long as I know my molecular weight class, so sabi natin moles, di ba? Equals to weight over molecular weight. Okay? So therefore, class, ang gagamitin ko lang dyan would be this formula here. So alam ko na moles yun. Okay, I can get my heat of vaporization as well. Pero most often than not, class, ang tatanungin lang naman sa atin dito would always be molar heat of vaporization. How much heat is needed to convert 1 mole of your substance back to, or convert 1 mole of your substance into its gaseous state. Okay? Or vice versa to, tandaan nyo. Pwedeng vice versa to. Okay? Magdadepende lang yan sa sign na gagamitin natin. Is it positive? Or makukuha natin? Is it positive or negative? Okay? So if I'm, again, converting my gas back to liquid, dapat ang heat of vaporization ko is negative. Meaning I should be losing that amount of heat. Okay? Are we good? Okay. Ayan, so here's sample problem, class. Pero this time, I'm not asking actually here for heat of vaporization. What I was asking here is, ano yung pwedeng mangyari sa system na to if I put this kind of heat, this amount of heat? Okay, how much pressure would be needed? So halimbawa, compute the vapor pressure of water at 120 degrees Celsius. Now, the vapor pressure of water at 120 degrees Celsius, tama. The vapor pressure of water at 100 degrees Celsius is 1 atmosphere. And the heat of vaporization is 972 calories per mole. Okay? So, given this one, class, right? So, isa-isay natin to. So, obviously, class, what do I need here? Okay? Kasi ang mangyayari dyan, ang mangyayari dito is, I'm going to increase daw. Okay, let's put this into context muna. This is my water. Right now, my water is having a heat. Okay? Ang heat na bina-absorb niya is equivalent to 9,720 calories per mole. Okay? Ito yung kanyang heat of vaporization. So, V up. Basta yun na yun. Heat of vaporization. Okay? Now, ang current temperature class ng water ko right now is 100 degrees Celsius. Right? At 1 atmosphere. Okay? At 1 atmosphere. Now, class, I'm going to give it 9,720 calorie mole of heat. Okay? Now, if that happens now, okay, yan yung ina-absorb niya. Yan na-absorb niyang heat. That's the total amount of heat absorbed per mole. Okay? Ano ang mangyayari, class, if I increase the temperature of my water to 120 degrees Celsius? Okay? Same amount of heat. Ito yung heat na ina-absorb ng aking system na to. Okay? If I increase the temperature, class, to 120 degrees Celsius, ang question dito is, how much vapor pressure is being exerted now? Right now kasi ang vapor pressure ko, VP na lang is 1 atmosphere. So, ibig sabihin, yung molecules na nag-evaporate dito is creating a pressure equal to that of the atmospheric pressure. Obviously, class, if I'm going to increase the temperature, it's going to increase the amount of pressure being exerted now, right? Tama? Okay, so tataas eh. So, tinaasan ko kasi ang temperature. So, obviously, tataas din yung vapor pressure. How much? By how much? Okay, so yun ang question natin ngayon dito. Okay? So, ang tamang answer dito question be 1.95. Right? So, let's try to solve it. So, kailangan ko is P2. So, obviously, lipat ko to si L1. Si Ln P1. Okay? So, usually, ang gagawin ko dyan is plus Ln P1. Plus Ln P1. So, mangyayari dito, class, would be Ln P2 is equal to change in heat of vaporization over R times 1 minus T1 minus 1 over T2, ano ba? Plus Ln P1. Okay? So try to put now our values. Ano ba meron tayo? Meron tayong heat of vaporization. Molar heat of vaporization. Ba yan? Wala masanay tayo. 9,720 calories per mole. Okay, over. So obviously, class, I'm going to have to find a yung gas constant ko that has calories in it. So therefore, this is going to be 1.987 calories per Kelvin. So times. Okay. 1 over, what's our first temperature again? Oh, 100 degrees Celsius. Okay, sorry. 100 degrees Celsius. So again, class, hindi tayo gagamit ng degrees Celsius here. We're going to use Kelvin. So convert that to Kelvin. So plus 273 equals 373, obviously. Tapos ang 120 would be plus 273 equals 393 kelvins. Okay? So, 1 would be 373. Tama ba? Okay, 373 kelvins minus 1 over 393 Kelvin plus natural log of 1 atmosphere. Okay? Okay. So now, ang gagawin natin dyan would be calories, Kelvin, dahil over denominator, so technically magiging numerator to. Cancel. Matitira na lang dyan would be mole per atmosphere. Okay. So matitira na natin dito would be atmosphere. 9,720 divided by 1.987. Get here a value of 4,891.7967 na lang. Times. So 1 minus 373, fraction na natin to. 1 over 373 minus another fraction, 1 over 393 equals Marami pa ng 0 to. So, times 0.000136 or plus ln1 class would give you 0 if I'm not mistaken. Tama, 0. Okay? So hence, multiply. You get, okay, take note, lnp2 pa to ha, lnp2. Okay? 4891.7967 times 0.1231364. You get, oops, asya pa ba? 0.06, ay, saan ba? 0.6672. Okay, 0.6672, ganyan. Okay? Atmosphere, pero, take note, lnp2 pa to. So I need to remove ln here and transfer it to the other side, correct? Kasi lnp2, kailangan ko lang dito is p2. Alright? So class, ano ulit na sabi kong opposite ni ln? It's E. Right? E. Okay? Euler's number. So class, multiply both sides of the equations by E. Okay? So ang mangyayari dyan class is, maka-cancel out yung ln ko dito. So magkakaroon ngayon ng E to. So ang nangyari dyan class is, magiging E raised to 0.6672. Ang Euler's number kasi class, ang ginagawa niya, para ginagawa niya exponent yung any number na kakabitan niya. Okay? So, 0.6672 and 0.6672, we get an answer of 1.94. Ayun, thank you very much. 87. 888 na lang. Or sabihin natin class, usually 2 decimal place lang naman ako eh. 1.95 atmospheres. So, ibig sabihin class, if my substance is able to absorb, okay, 9,720 calories per mole. Okay, so again, this is the amount of heat needed to convert 1 mole of your liquid to vapor. Okay, so if I change the temperature to 120, I can now expect that the vapor pressure will be increased to 1.95 atmosphere, which is a lot higher than the atmospheric pressure. Right? So are we good? Okay. Most often than not, class, kapag ang inyong vapor pressure is much higher than your, tawag dito, is equal to the atmospheric pressure or much higher than the atmospheric pressure, makikita mo, class, the liquid starts to form bubbles. Okay? Pag ang tubig mo kasi, pag nagpapakulo tayo, sa umpisa, umusok-usok lang yan. Ibig sabihin, some of the molecules are turning into vapor. Okay? At the same time, it's already exerting vapor pressure. Okay, tumataas na yung vapor pressure. Pero pag nakakita na kayo class na may bubble formation na, that only indicates that the vapor pressure of your fluid is already equal to that of the atmospheric pressure. Okay? Or it could actually be much higher than that. So, boiling point. Actually, na-mention ko na to, pero ulitin ko lang. Sabi nga natin class, it's the temperature at which the vapor pressure of the liquid, okay, the vapor pressure of your liquid is equal to the external or atmospheric pressure. Okay? Another thing nga pala class, you can use the equation of, okay, yung Clapeyron equation class, pwede natin gamitin, say for example, at room temperature, okay, at whatever vapor pressure meron man ngayon yung liquid mo, pwede natin gamitin yung class to determine how much vapor pressure it will exert once it starts boiling. Pero again, normally naman, alam natin na it should be at the same atmospheric pressure, at the same pressure as that of the atmospheric pressure. Okay, pero anyway, basta yun lang isa sa mga applications noon. So, this is the temperature at which class the vapor pressure of the liquid is equal to the external or atmospheric pressure. So, if the atmospheric pressure class is 1 atmosphere, okay, the vapor pressure should also be equal to 1 atmosphere. Pag ganyan na yan, class, mag-start na mag-form ng bubbles. Now, these bubbles, class, can form and rise since the vapor pressure can already overcome the atmospheric pressure. So it's either equal to atmospheric pressure or higher than the atmospheric pressure. Normally, class, if your liquid has not yet reached the atmospheric pressure, okay, bubbles cannot form. And since the vapor pressure is less than because since the vapor pressure is less than the atmospheric pressure. So kumbaga, hindi niya pa kayang labanan si atmospheric pressure, so wala ka pang nakikitang umaangat na gases. Nagets ba? Okay, wala pang umaangat kasi hindi ko pa na-beat yung atmospheric pressure. Right now, class, the atmospheric pressure is pushing my fluids down. It's pushing my fluids down. Since I haven't beaten it yet, kumbaga yung vapor pressure ko, gumaganon pa lang. Okay, di ba ang vapor pressure paakyat? Alright, paakyat siya kasi nagtuturn na siya ang liquid into gas state. Habang umakyat class yung vapor pressure, pino-push back siya ni atmospheric pressure. So hence walang bubbles na form. Pero taasan ko pa ang temperature, or once that the temperature has reached, was able to create or was able to produce a vapor pressure equal to the atmospheric pressure, so therefore pantay na tayo, sabi niyang ganun. So hence bubbles start to form. These bubbles class are vapor forms of our vapor forms of the liquid. Actually, ang vapor forms, nakikita mo na, umuusok-usok yan. Okay? Pero the whole liquid itself is starting to vaporize. Nagets ba, class? Pag bumubula na ang inyong, tawag dito, ang inyong liquid, that only indicates that the entire system is starting to vaporize. Kanina, class, habang hindi pa yan kumukulo, topmost lang, or the molecules with the highest energy is the only one that is converted into its vapor state. Okay, kaya wala pa masyadong wala ka pa makikitang kumukulo dyan. Usually sa surface lang lumalabas. Okay, ng fluids natin. Okay? So, sabi nga natin, ayan, water at 90 degrees, kunwari 525 torr. Torr class is another unit for, tawag dito, is another unit for pressure lang naman. Okay? So anyway, so 760 torr, that's equivalent to 1 atmosphere. Okay? So, sabi natin ng water ko, kunwari nung pinapakuluan ko, 525 torrs pa lang siya. Okay? Now, I increase it to 100 degrees Celsius. Pinataas ko to 100 degrees Celsius ang aking temperature. Ang temperature ng water ko, okay, again kasi, it's the water, the temperature of the water, not your hot plate or your Bunsen burner. Ito ang pagkakamali kasi lagi ng mga estudyante ko. Dati nagpapapractical ako. Okay? Ano ba, bibigyan ko ito. Ito yung amount of heat absorbed. Ano expected mo ngayon na vapor pressure pag tinaasan mo ang temperature into ganito. Okay? Ang kinukuha nilang temperature class is the temperature of the hot plate. Again, we're not talking about the temperature of the hot plate. We're talking about the temperature of the water, of the fluid that you're boiling. Are we clear? So baka mamaya kasi class, ilagay ko sa example. Mare, mapagtripan ko. Okay, the temperature of the hot plate is currently at 260 degrees Celsius, while the temperature of the water is at 100 degrees Celsius. Kumari lang naman. Okay, stuff like that, class. So, yun. At saka, yun yung application nito eh. Okay, docs? So, again, it's the temperature of that water. So now, class, if the water is above 100 degrees Celsius na, then obviously, class, the amount of the fluids here most likely would be gone na. Above 100 degrees Celsius na yung temperature niya. Okay, so mawawala na kasi mag-vaporize na siya completely. Lalo na pag na-meet niya na ang kanyang critical temperature. Alright? Then that liquid will completely convert itself into gaseous state. Wala na matitira sa basong ito. Okay? Now, again, class, all the heat absorbed is used to change the liquid into vapor. Now, the temperature does not usually rise, class, until the liquid is completely vaporized. Right? Remember, class, kaya nga, ang hirap kasi hindi kayo nag-experiment eh. Halimbawa, class, if you want to keep a constant temperature, kunwari, you're trying to mix something, a chemical, okay? You want to maintain a temperature of 90 degrees Celsius, halimbawa. Oftentimes, class, gagawin mo yan under a water bath. Have you heard of the term water bath?
Yes po, sir. Yes,
Okay, di ba sa techniques to, sa calculations to eh? Sa farm nyo, right? Nabanggit yung water bath. Water bath kasi, class, ginagamit yan to maintain the temperature at a relatively constant state. Okay? So meaning, at least kahit paano, may iwasan ko na mag-fluctuate yung temperature ko. Especially if the mixture that I'm trying to mix, class, is very heat sensitive. So usually gagamit ako ng water bath kasi nga water, as long as hindi naubos yung water mo, hindi siya completely nag-volatilize, hindi siya completely nag-evaporate, very resistant to changes in temperature siya. Okay? Water will be very resistant to changes in temperature. Very good? Okay. Now, what usually affects, class, the boiling point, another significant thing that would affect the boiling point, sabi nga natin, would be atmospheric pressure. Okay? So the atmospheric pressure, class, at sea level is approximately 760 millimeter of mercury, Or 760 millimeter of mercury class is equivalent to 1 atmosphere. Okay, at higher elevations, what do we expect from the atmospheric pressure? Ano ba, umakyat ako ng bundok. Namundok ako. So habang umakyat ako ng bundok class, ang pressure bumababa. Kaya nga nahihirapan tayong huminga. Usually pag nasa tuktok ka, di ba? Kaya kailangan kadalasan pag aakyat ka ng Mount Everest halimbawa, kailangan may oxygen ka na bitbit. Kasi sobrang nipis ng hangin doon kasi baba ang pressure. Okay, because mababa ang pressure at higher altitudes. So therefore class, pressure kasi, kapag mababa ang pressure, pag mababa ang pressure class, ang tendency, boiling point also decreases. Sabi nga natin, directly proportional si temperature at saka si pressure. So pag mababa ang available atmospheric pressure, then class, the boiling point would also be lower. So look at this. At a pressure of 700 millimeter of mercury, ang boiling point na lang class ni water is 97.7 degrees Celsius. Lalo na class, pag pumunta ka sa, okay? Lalo na pag mas mababa pa ang pressure, halimbawa. Okay? 17.5 millimeter of mercury. Then class, only at 20 degrees Celsius, water will start to boil. Okay? Pero of course, parang wala naman yatang ganito kababang pressure sa natural environment. Okay? Pero yun class, habang umakyat ka ng bundok, mas mababa yung boiling point. Okay? Yun lang gusto ko yung point out dito. So the change in boiling point class with pressure can be computed using, again, the Clausius-Clapeyron equation. Next one, class, is the latent heat of vaporization. What do we mean, class, when we say latent heat? Okay, the latent heat, okay, it is the heat that has to be given to a unit mass of material to convert it from liquid to the vapor phase without a change in temperature. So meaning, class, when I say latent heat, okay, latent heat of fusion or latent heat of vaporization, pag sabi ko, class, latent heat of fusion, meaning is the conversion of solid to liquid or liquid to solid. Okay, in short, this is melting. Melting or freezing point. Okay? You might be wondering, sir, melting and freezing point, pareho lang ba yun? Okay, you might be wondering, right? Okay, tingnan nyo to, class, ha. Depende kasi kung saan phase ka nang gagaling. Okay, it depends on what phase you're looking at. At 0 degrees Celsius, sabi natin, ice, water, turns to ice, correct? Tama ba? At 0 degrees Celsius, right? Water turns to ice. Nagiging yellow yan. Pero class, kung iisipin mo, at 0 degrees Celsius, therefore, this is freezing point, right? This is a freezing point. This is the freezing point of ice. Okay, 0 degrees Celsius. Class, kung iisipin nyo, at 0 degrees Celsius, an ice starts to melt into water as well. Nagets ba? Nagets ba, class? Kinda? Okay. Isipin nyo to, yellow, ice. Okay, tubig na lang muna, tubig muna. Tubig, pag nilagay ko siya sa 0 degrees Celsius, nag-uumpisa na siyang tumigas. Tama? Hindi pa yun yung critical temperature for it to freeze, pero umuumpisa na siyang tumigas, correct? Hindi pa siya completely titigas, pero siya ay nag-uumpisa na maging yellow. Nag-uumpisa na maging yellow, correct? Pero class, bigyan kita ng isang buong yellow. At 0 degrees Celsius, nag-uumpisa na rin yung matunaw. Nagas niyo ba? Kaya class, ang melting point, basta provided class, this is the same substance. Okay? The melting point of a substance is also its freezing point. Okay? If it transitions from one phase to another. So are we clear? So I hope that's nagigets naman, class. Okay? Kasi yung latent heat of fusion na yan, class, gagamitin natin to mamaya. Mamaya ba? Hindi, mamaya sa solid. Next time na probably sa solids. Okay? Kasi the conversion of solid to liquid or back and vice versa. Again, class, ang difference lang naman kasi dito is, if I convert solid to liquid, then I'm adding heat. But if I'm converting liquid, liquid back to solid, okay, ang nangyayari lang dyan, class, I'm losing heat. I'm going to lose heat. Right? Kaya class, ang latent heat of fusion ko, or ang heat of fusion ko, will just simply be either positive or negative. Okay? If it's positive, then it means I'm gaining heat. I'm converting a solid to liquid. Pero kung ang latent heat of fusion ko is negative, then it means I'm converting a liquid back to going to its solid phase. Okay? Okay. So yun yun. So anyway, class, dito rin sa latent heat of vaporization, okay, dito class nag-uumpisa ang evaporation. At the same time, dito rin nag-uumpisa ang condensation. Right? Dito nag-uumpisa ang evaporation, dito rin nag-uumpisa ang condensation. Especially if you start reaching what we call the dynamic equilibrium. Remember that? It's the temperature at which the amount of evaporation is equal to the amount of condensation. Okay? Now, class, ang latent heat of vaporization na to, this is the point at which, class, even if I increase, temperature remains constant as the liquid turns to gas. Okay? Nung nag-umpisa na siya maging gaseous, temperature is kept at a constant rate. Pero the heat supplied is increasing. Okay? Tumataas yung heat ko dito. But the temperature remains the same. Okay? Once you reach that point, class, in the conversion or in the transition, sorry, mas magandang term transition, the transition of liquid to gas, wherein I keep adding heat, pero hindi nagbabago ang temperature ko, it means you've already reached what we call the latent heat of vaporization. So, heat absorbed when liquids vaporize and are liberated when the vapors condenses to liquids, blah, blah, blah. Okay, normally, class, water vaporizes at 539 calories per gram or 9,720 calories per mole. Okay? Or at the boiling point of 100 degrees Celsius. The boiling point, class, may be considered the temperature at which thermal agitation can overcome the attractive forces between molecules of the liquid. So, tandaan nyo lang, class, boiling point, okay, yung boiling point na yan could be a marker. Okay? Could be a marker, yun na lang, mas magandang term. Marker, class, kung saan masasabi natin that the molecules is starting to separate from each other. They are starting to overcome the attractive forces. Hence, they are starting to convert into gaseous state. Kasi nagbe-break na yung van der Waals forces existing between the liquid molecules. Kaya nagiging gaseous state na siya. Alright? Okay. So another property, class, of our liquid, again, it possesses surface tension. It's the property of the surface of a liquid that allows it to resist an external force due to its cohesive nature, due to the cohesive nature of its molecule. And then, of course, class, liquids have what we call a flow property or viscosity. Pag-aaralan natin ito sa rheology na. Okay? Pati yung surface tension. Pero basically, class, liquids are able to flow. Okay? Pag binuhos mo siyang ganyan, di ba, may tinatawag tayong laminar flow. Okay, wherein, basta may flow yan. Right? Viscosity is defined as the resistance to flow of fluids due to internal friction of a moving fluid. A good example would be comparing pancake syrup with that of water. Okay, di ba? The syrup, class, would flow slowly due to its increased viscosity as compared to water. Pag binuhos mo, isang ganun na lang. Okay? So the more viscous a drug is, the less would be its flow property.